Look up at the night sky, and you will see stars, planets, nebulae, and distant galaxies, bright, glowing, and full of light. But what if I told you that everything you can see, every atom that makes up you, me, the Earth, the Sun, and all the stars in the Milky Way, adds up to just 15% of the universe's total mass? The other 85%, the overwhelming majority of what fills our cosmos, is completely invisible. It does not emit light, absorb light, or reflect light. It does not interact with ordinary matter through the electromagnetic force, the very force that lets us touch, see, and feel the world around us. We call this mysterious hidden substance dark matter. It is the silent architect of the universe, the invisible glue that holds galaxies together, and the greatest unsolved puzzle in modern astrophysics. Today, we diving deep into the story of dark matter, how we discovered it exists, why it is essential to our cosmic story, and how we hunting for a substance that we cannot see, hear, or touch. The first hint of dark matter's existence came not from a space telescope, but from a brilliant, unconventional astronomer named Fritz Zwicky in 1933. Zwicky was studying the Coma cluster, a massive group of more than 1,000 galaxies bound together by gravity. He calculated the total mass of the cluster by measuring the speed at which its galaxies were moving. According to Newton's laws of gravity, the faster the galaxies moved, the more mass the cluster must have to keep them from flying apart. What Zwicky found shocked him. The visible mass of all the galaxies in the Coma cluster was far too small to explain their orbital speeds. The galaxies were moving so quickly that they should have escaped the cluster's gravity long ago, scattering into the emptiness of space. But they didn't. There was something invisible, something with enormous mass holding the cluster together. Zwicky called this missing mass Dunkelmaterie, German for dark matter. At the time, most astronomers dismissed his findings as a miscalculation, a flaw in his observations, or a misunderstanding of gravity. For decades, dark matter remained a forgotten footnote in astronomy, a strange idea that no one wanted to take seriously. That all changed in the 1970s, thanks to an astronomer named Vera Rubin. Rubin was not studying massive galaxy clusters. She was looking at individual spiral galaxies like our own Milky Way. She measured the rotational speed of stars at different distances from the galaxy's center. According to standard physics, stars farther from the center should orbit more slowly, just as Pluto orbits the Sun more slowly than Earth. But Rubin's data revealed a stunning truth. Stars at the outer edges of galaxies were moving just as fast as those near the center. There was not enough visible mass, stars, gas, and dust to create the gravity needed for this rapid rotation. The outer stars should have been flung into deep space, but they stayed locked in their orbits. The only explanation was an invisible halo of mass surrounding every galaxy, a hidden shell of material that provided the extra gravity to keep the galaxy intact. This was not a fluke, not a miscalculation. It was proof dark matter is real, and it surrounds every galaxy in the universe. Rubin's work was groundbreaking, and it finally forced the scientific community to confront the reality that the universe is dominated by something we cannot see. Since Rubin's discovery, astronomers have found countless other pieces of evidence that confirm dark matter's existence. One of the most powerful is gravitational lensing. Einstein's theory of general relativity tells us that mass bends spacetime, and when light passes near a massive object, its path is curved, like light passing through a lens. When we observe distant galaxies behind a massive cluster of galaxies, their light is bent and distorted by the cluster's gravity. By measuring this distortion, we can map the total mass of the cluster. Time and again, the results are the same. The visible mass is only a tiny fraction of the total mass needed to create the observed lensing effect. The rest is dark matter. We can even create detailed maps of dark matter distribution across the universe, showing its invisible, web-like structure that serves as the scaffold for all visible galaxies. Another critical piece of evidence comes from the cosmic microwave background, the faint afterglow of the Big Bang. This ancient radiation holds the imprint of the universe's earliest moments, and tiny variations in its temperature reveal how matter was distributed in the first seconds after the Big Bang. Without dark matter, these variations would not have been strong enough to pull ordinary matter together to form stars, galaxies, and galaxy clusters. Ordinary matter alone is too sparse and too hot to clump together quickly. Dark matter, however, does not interact with light or heat, so it began clumping first, creating gravitational wells that pulled in ordinary matter, like water flowing into a bucket. Dark matter is the backbone of cosmic structure, Without it, the universe would be a cold, empty soup of scattered atoms, with no galaxies, no stars, and no life. We owe our very existence to this invisible substance. You might be wondering, if dark matter is invisible, what is it made of? Scientists have proposed dozens of theories, but two leading candidates stand out. The first is WIMPs, or weakly interacting massive particles. WIMPs are heavy, slow-moving particles that only interact with ordinary matter through gravity and the weak nuclear force, one of the four fundamental forces of the universe. They fit perfectly with our current understanding of particle physics and cosmic evolution. The second leading candidate is axions, tiny ultralight particles that are even harder to detect than WIMPs. Axions were first proposed to solve a problem in nuclear physics, but they quickly became a top candidate for dark matter. Both particles are invisible, neutral, and do not interact with light, exactly the properties we need for dark matter. The hunt for dark matter is one of the most ambitious scientific endeavors in human history. Scientists have built massive detectors deep underground, far away from cosmic rays and other interference, to catch a single dark matter particle colliding with an atom of ordinary matter. Experiments like LUX, Zeppelin, Xenont, and Pandax XPT are buried miles beneath the Earth's surface, using ultra-cold liquids and sensitive sensors to look for the tiny burst of energy from a dark matter interaction. Meanwhile, particle accelerators like the Large Hadron Collider at CERN are trying to create dark matter particles in a lab, recreating the extreme conditions of the early universe. Space telescopes like the James Webb Space Telescope and the Euclid satellite are mapping the distribution of dark matter across the cosmos with unprecedented precision, looking for clues about its nature and behavior. Every day, we get closer to solving the mystery, but so far, dark matter has eluded every direct detection attempt. What makes dark matter even more fascinating is how it defies everything we think we know about matter. The ordinary matter that makes up our bodies, our planet, and our stars is made of protons, neutrons, and electrons, particles that interact with light and with each other. Dark matter is entirely different. It passes right through ordinary matter, as if it's not there. You could be sitting in a room right now, and trillions of dark matter particles could be passing through your body every second, leaving no trace, no sensation, no evidence of their presence. It is the ultimate ghost, everywhere, all around us, shaping the universe, but completely undetectable by our everyday senses. This invisible dominance raises profound questions about our place in the cosmos. For centuries, humans thought we were at the center of the universe, that we were the main event. But astronomy has repeatedly humbled us. We orbit an ordinary star in an ordinary galaxy, in a universe where 95% of everything is either dark matter or dark energy, the other invisible force driving the universe's expansion. We are made of normal matter, but normal matter is the exception, not the rule. We are the cosmic afterthought, the small 15% that exists because of the invisible 85%. Dark matter teaches us humility. It reminds us that the universe is far stranger, more mysterious, and more wonderful than we can ever imagine. As we look to the future, the search for dark matter will continue to push the boundaries of science. Solving the dark matter mystery will not just tell us what the universe is made of, it will rewrite our understanding of gravity, particle physics, and the Big Bang itself. It could reveal new forces of nature, new particles, and new laws that govern the cosmos. Every telescope we build, every detector we design, every observation we make, brings us one step closer to lifting the veil on this invisible giant. We may not know what dark matter is yet, but we know it is there, holding the universe together, waiting for us to uncover its secrets. The universe is full of wonders we can see, but its true power lies in what we cannot. Dark matter is the quiet hero of the cosmos, the invisible hand that guides the stars, builds the galaxies, and makes our existence possible. It is a reminder that there is always more to discover, always more to learn, and always a vast mysterious universe waiting to reveal its truths to those who dare to look beyond the light. Please like, comment, share, and subscribe to the channel.